Today I'm going to teach you how to protect the diols. If your molecule contain this type of diol, then you can protect that diols with the help of 2,2-dimethyl acetal by reacting with the ketone and acidic condition. Second reagent you can use the 2,2-dimethoxypropane. The structure of 2,2-dimethoxypropane is like this. Under acidic condition you can protect your diols. And the third is a phosgene, also you can take in presence of pyridine as a base. Okay. Let's see the mechanism how diols are protected by the ketones. Means how can you protect your diols as a acetal in presence of ketones and acidic condition. First, your ketone is protonated by the acid like this oxygen lone pairs attack on this hydrogen and you get the protonated ketone form. And then here is a electrophilicity generated, because this we know that in the carbonyl group the always the resonance takes place and oxygen is more electronegative. That's why the electron push toward the oxygens and carbon bears a positive charge. That's why the diol, one of the OH of diol molecule, the lone pairs attack on this electrophilic carbons, and this pi electron shifted toward the oxygen and you get this type of intermediate like just oxygen. Okay, like this you get. And again this hydrogen, this oxygen has a hydrogen. Okay, this oxygen bears a positive charge because it loses its lone pairs, and we know that electronegative atom cannot bear a positive charge. That's why just a hydrogen transfer takes place here. This OH attack on the this hydrogen, this lone pair of oxygen attach on hydrogen and OH2 is formed. In the next step, another OH molecule is present in your structure, means that will attack on this carbon. Okay, that will attack on this carbon and this OH2 group will eliminated. And now you will get this oxygen, okay, as a acetal. Here there will be the hydrogen and the positive charge of oxygen, but in the later state hydrogen will be lost. Okay, and you will get this is like a protected form of your diols. When we use the protection in molecules, whenever there are more than two or three functional groups, two functional groups are present and we want to just reaction to one functional group, that time we use these types of protection group. Now let's see another protecting group is 2,2-dimethoxypropane. What happens in case of 2,2-dimethoxypropane in the acidic condition? First, the one of the OMe group is get protonated. When it gets protonated, the time the lone pairs of this oxygen shift, here's an O-methoxy group remove. Here the O-methoxy group is a good living group, that's why it's easily eliminated and you get this intermediate. Now here your diol molecule, the lone pairs of these diols molecules attack on this carbon. Okay, this electron shift toward the oxygen. Okay, in the next step just proton transfer takes place. This OH to make it a good living group, it become OH2. Again this lone pairs attack on this carbon, OH2 groups removes and you get to protonated forms of your diol. This is the mechanism of in presence of 2,2-dimethoxypropane. And if you want to deprotect these groups, how can you deprotect? There is a very easy fundamental thing, just let me explain you how can you deprotonate that groups. Now let's see the deprotonation of this acetal group. It's also similar to with the 2,2-dimethoxypropane. First your oxygen is get protonated under the acidic condition. Here the positive charge is generated, that is why this bond is glue. And now your this group has a positive charge because it loses its bonding electrons. In the next step, the water act as a nucleophile which act as on attack on this positive charge of this carbon, this which is attached here. In the next step just a proton transfer takes place. Okay, next step proton transfer means just attach this, yeah, just a proton OH2 is like OH2. Okay, this proton transfer takes place. This become the OH. Okay, this become the OH. Now to neutralize this positive charge, again this bonding electrons are shared to the oxygen, and you get this diol. And also the byproduct is like this, because this is the oxygen. Okay, it behaves the positive charge. This bond is break, oxygen bond breaks, and you get propene as a by sorry not propene, acetone as a final byproduct. Okay, this is the mechanism of protection and deprotection of diols. If you need this type of videos, then please like and subscribe my channel. Thank you for watching, guys.